Hey subscribers, this is the first in a playlist of videos looking at things like product of primes, multiples, lowest common multiples and highest common factors. So a lot of this first video is going to be a recap of stuff that you've done in previous years. So if we're going to start off with product of primes, which is what this video is going to look at, we'll do a quick true or false and spot the mistake. So here you've got 180 written as a product of primes, prime factors. Which of these are correct, which of these are wrong, and if they're wrong, spot what is wrong with them. So pause the video and have a go with that first. Okay, I'm going to tell you the answers in 3, 2, 1. So we can see here that the first answer is wrong because it's not a product, it's an addition, so that doesn't work. Although it does add to 180, it's not a product, and they're not prime factors. The second answer is not written as a product either. There should be a multiplication sign in between the numbers here, so again this doesn't work without the signs. Question 3 does multiply to 180, so it is a product, but it's not a prime number, so that also doesn't work. The fourth example does work, so we can see this is a product of primes, so we can double check that this does multiply to 180. So 2 times 2 is 4, times 3 is 12, times 3 is 36, times 5 is going to give you 180, so that works. And in the last example here, you can see the 3 squared is there, the 5 is there, but the 2 times 2 is written as a 4. So although that will give you 180, that's not a prime number, so this doesn't work. So there's only one correct answer, which is this one here. So this is just a quick recap of recognizing product of primes and also not making any of these silly mistakes. The most common mistakes you kind of come across is this one here. Usually it's this one here. People accidentally write numbers like 9, for example. They'll think that they're prime, and sometimes people will list the factors and not write it as a product. Alright, let's do some practice on writing something as a product of primes. You hopefully can remember when you're asked to write something as a product of primes, you use upside down bus stop. You find a prime number that goes into 45, so we'll just list the prime numbers. For the first example, we know there's 2, 3, 5, 7, 11, 13, and they go on. But in this case, we're just going to divide by 5 to get 9. We're going to divide by 9 by 3 to get 3. We're going to divide 3 by 3 to get 1. So here you can see we've got, if you write this in numerical order, 45 is equal to 3 times 3 times 5. That's your answer. Make sure you don't do any of the silly mistakes. For example, like on the previous slide, people write this. That would be wrong because it's not a product of primes. It's just a list of prime factors. Okay, second, now for you to try a few of these examples here, pause the video and then I'm going to go through these. Okay, I'm going to do this in 3, 2, 1. Okay, so question 1, divide by 2 is 12. Divide by 2 is 6, divide by 2 is 3, divide by 3 is 1, so this would be 2 to the power 3 times 3. You can write this the long way as well. You can write this as 2 times 2 times 2 times 3, so 63. We're going to need to pick a prime number that fits in 63. So it's usually easier to pick nice numbers like 3, so 63 divided by 3 is 21. We're going to divide this by 7 to get 3. We're going to divide this by 3 to get 1. You may have done a different order, but either way you're going to get 3 squared times 7. This example here, we are going to divide by, let's divide by 2 to get 70. Divide by 7 to get 10. Divide by 5 to get 2. Divide by 2 to get 1. So 140 can be written as 2 squared times 5 times 7. And then finally 14 divide by 2 to get 7, divide by 7 to get 1. So 14 can be written as 2 times 7 if it's a product of primes. Okay, hope you got those all correct. That was just a quick recap. Pause the video, fill in the blanks, and then I'm going to show you the answers in 3, 2, 1. Okay, so here are the answers. We know that there's going to be 2, there's going to be 3, and 5 cubed. For question C, you should have got y, and for D, you get 2 cubed, which is 8. And here it's going to be 2 squared. Now, this is an interesting one. The last question, 32, can be written with a base of 2, which can be 2 to the power 5. And then when you square it, it's the same as 2 to the power 5 times 2 to the power 5. Using laws of indices, you're going to get 2 to the power 10. Okay. Finally, quick true or false. Pause the video and decide whether these are all true or false, and then I'm going to go through them. Okay, if you need more time, pause the video. Here come the answers. As a product of prime factors, 27 is 3 squared. So I meant to say 3 cubed. This is true. As a product of prime factors, 21 is 3 times 7. We can see that this is also true because 3 and 7 are prime. Therefore, as a product of its prime factors, 210 is 3 times 7 times 10. Now this is false because the 10 has to be written as 5 times 2. So this hasn't been decomposed. Okay, question 4. As a product of prime factors, 12 is 1 times 2 squared times 3. Well, 2 squared is 4 times 3 is 12. However, 1 is not a prime number. So it's not written as a product of prime factors. Question 5. As a product of prime factors, 13a is equal to 13 times a. Now 13 is a prime number, so in this case you can say that's true. Technically a isn't prime, so this is a questionable one. This will only be true depending on the value of a. So this is a bit iffy. We'll leave that one as depends. For example, if a is 1, then 13 times 1, that's not going to work. So let's say this is false without more information. Question 6. As a product of prime factors, 48 is 3 times 2 to the power 4. So 2 times 2 times 2 times 2 is going to give you 16. 16 times 3 is 48. So yes, this does work. That is true. Okay, see you in the next video. We're going to look at things like we're going to look at multiples, lowest common multiples, and highest common factors.